Hi there. Hello, everyone. Welcome to Code Konyo. So for today, let's uh, visit some of the predefined or built-in functions on Python sets. So there are functions in sets that are actually useful in terms of if you're going to do probability and statistics and do some machine learning in the future. So this time, let's have subset. So when we talk about a subset, or is actually it's going to return either true or false. So I mean, basically, when we talk about a subset, this method actually returns true if all the elements of a set are present in another set. So it's going to return false if otherwise not. So let's say for an instance, we have here the elements of our sets, and let's have here, okay, so let's have here A, B, C, and then let's say we are going to have or print A is subset. Yeah, so let's have here 2, 4, 6, 8. Okay, and let's make this as let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And let's have C as say, let's say 2, uh, 4, and 8. So let's say we are going to test if either A is a subset of B or B is a subset of C. So let's say we have here is subset. So A is a subset of B. So this will give us a true because a true result because all the elements in A are present in B. Now, in the case of, let's say, we want to have here A is or B is a subset of A. So this will give us a false result because again, not all the elements of B are in actually in A, and it's as you can see, A is actually its cardinality is less than the cardinality of B. So basically, it's not a subset of B is not a subset of A. Now, how about if we are going to get the evaluation either if A or C is actually a subset of A. So notice that you have here 2, 4, and 8, and then you have 2, 5, 6, and 8. So uh, 2, 4, and 8 are the elements of C, while in A, 2, 5, 6, and 8. So is this a subset or is C a subset of A? So obviously not, because the not all elements in C are in A. Particularly, C doesn't have element 6. But if you're going to uh, like C is an element of B, obviously this will give us a true result because all elements of C are actually present in the element of B or set B. Okay, now let's proceed on the is disjoint. So disjoint is a Boolean function which is also going to return true or either false. It's going to return true if two sets are disjoint sets, meaning if not all if they don't have elements that are common to both sets. So meaning to say each of the element of that two sets or two or more sets that you are joining are actually unique. Okay, so let's say for an instance we have here let's change this to, let's say, uh, 11, 12, 15, and 20, or 20. And let's have 2, 4, 8, 15, and 16. So let's make use of the disjoint. So we have here A that is disjoint. So you have disjoint. So right here, if you're going to print A dot disjoint B, so basically this will give us a true because they don't have anything as their elements that are common to them. So because elements in the all elements in A are unique, com- if we're going to compare it with B, okay. So how about A disjoint C? So obviously, this will give us a um, false because some elements in A are actually in C. Particularly, we have 15. Yeah, and I guess it's only 15. So that's actually disjoint set or is disjoint. So if you're going to like explore more of this, you might one I mean you can also discover a lot of functions right here in set. So you can have here add, so you can actually add a let's say I am going to create here a set, sorry, this is a tuple. So I have here, let's say, yeah, we can actually add the uh, an element in our set A. Let's say we are going to add 9, and then we can also add as a set. So, but this time let's just print here the elements of A. So, and then let's have here A dot add. But this time we're going to have here, let's say A dot add. Sorry, B is equal to, let's say, uh, negative 5, negative 10, negative 15, negative 18. Okay, and then if you're going to, let's say, print add D, this will give us a, okay, so notice that in the A, as you can see, sorry, just wait for a while. Let's, because I lack D in my print. So I just have to for a while. I just have to comment this one. Okay. So in the A, notice that A is actually added with the value of 9 there in our set. Okay, as we print it out. And then with the D, we created a tuple here. Let's say negative 5, negative 10, negative 15, and negative 18. And this time, it has now a set of value which or elements which are negative 5, negative 10, negative 15, and 18 as a set included in A. So that's again, because it's an object and it's a set, we can also add it automatically as it is iterable. Okay, another thing we have a that, let's say, mm, update. So you can also do a dot update b, and if you're going to print the a or the value of a now, this would give you the all the elements of a and b. Okay, so and you have here the pop. Okay. So in the pop element, you have the pop. Basically, it's the idea is taken from the stack algorithm, and the pop is actually that's based on stack last in first out. So this would actually uh, remove the element. So this remove the elements. Say, let's have here its definition. So wait for a while. So let's. I would just like to be clear. I mean, just to be sure, certain or sure. So you have remove and return arbitrary set element traces. Key error if the set is empty. So since we have here a that uh, pop, So we're going to print this one. Wait for a while. Okay, so let's print it. So you have there, let's, wait. Yeah, pop takes no argument, sorry. So, okay, so A that, the update of our A is this one. So you have here, it removes this one. So if you're going to, and I mean, it removes the element one. And then if you're going to run or invoke multiple uh, pop functions, this is going to remove the two. So, and then if you're going to like call another pop, this will remove the entire set, which we have just added here in D as -5, -10, 15, because they are as they are treated as one set. Okay. So I guess there are still there's actually a lot of methods or functions we can use. Honestly, I'm not familiar of some of them. So you can also clear. So to take back the or to reset your set. So with its cardinality to 0. And yeah, so I guess just explore on those functions that are not discussed. And this is what set is all about. So thank you guys for watching this video. Have a great day ahead and bye bye.